Okay, let's start. A student has a spring of unknown spring constant K vertically attached one end of the stand as shown in this figure 1. The other end of the spring has a small loop from which the small cylinders can be hung in addition to the spring. The student has access only one variety of center of unknown mass, stopwatch and a digital scale. So design an experimental procedure that the student could use to determine the spring constant of the spring. Okay, K we have to determine. In the following table, list the quantity. In the space of the table, describe the overall procedure. Okay, we have to tell the procedure. Okay, so this we have to fill up. So in this quantities to be measured that we have to add, symbols that we are going to use, stopwatch and decision expression, and procedure we have to tell. Okay. So one of the method is to hang this mask on it. Okay. And when it is a stretch condition, just stretch it. It would be stretched, right? After coming to the equilibrium, you can find x delta x the displacement. So mg is equal to kx at a point at equilibrium point. Okay, so you can find the mass, and with the help of mass you can find the k value. Okay, but in this, if you see, x you have, this is initial displacement and this is final displacement. With the help of meter scale,
Yeah.
but we don't have a meter scale. We have a digital stopwatch and a digital scale. Yes, so what we can do, instead going by x method, uh, we have we have digital scale. We can measure the mass, and can we use this formula to pi root of m upon k. M is the mass and k is the spring constant and t is the period. So when the oscillation, like we have a stopwatch, so we can measure, okay, one oscillation, two oscillations, or to complete three oscillations, how much time is there. Measure this with the help of a stopwatch. Okay, this we can measure with the help of digital scale. We can measure with the help of a stopwatch. I think this is constant and we can find k. So we have to write the experiment. So I can write, with the help of a stopwatch it is time, and with the help of it is m. So it's mass of clock and this is time period. Okay. So first, measure the mass, measure a mass and hang it with the spring. Hang it on a spring. Okay. Initial push or a displacement. Like give an initial displacement, which is your amplitude also. So initially you just pushed it down, amplitude, and at this moment measure one oscillations or two oscillations, because one why we are not selecting one oscillation, time for one oscillation, because that would be very quick, so the chances of error would be increased. So like you start the stopper and immediately you have to stop, so it's better you take two oscillations times. Okay, two oscillation time. It is for two time period, like for two oscillations. So the time would be t is equal to the time you have selected, that is you have to divide by 2, you would get the time period. And then repeat 3, repeat second procedure, second point for the same mass.
Okay.
Okay, like you just confirm whether you are like your readings are correct or not. So for the same mass, you take 2 3 readings. So it would be T1, T2, T3. So you would get T1, T2, T3. okay, or T4, and you just take the average now, okay. So you would get the T for a single mass, okay, and this way you would get 1 T, right, one time period for one mass, okay.
Yeah.
And the next procedure is repeat 1, 2, 3 for second mass, for second, third, fourth, or fifth mass. Like this, from this you would get T1 final. So this is T1 final, right? The average of all. So you would get T1 final, T2 final, T3 final, T4 final, and T5 final. So this is for M1 mass, this is for M2 mass, this is for M3 mass, this is for M4 mass, and this is for M5 mass. This readings you have to correct. These data you have to correct. You can make a table and write all M masses and the T mass. Okay. Now in the B part we have to explain like how we are going to calculate this data or use this data to get the result. So let's see.
Mm-hmm.
Indicate the quantities that could be plotted to produce a linear graph whose slope can be used to determine the spring constant K. So on vertical axis and on horizontal axis. So what was the formula? So it was, so I can write T as 2 pi root of mass upon K. Use it as a slope. I have to change it like it would be T upon 2 pi, square of it is equal to M upon K. Okay, or I just write it here. So this would be T square upon 2 pi square into K is equal to M. I can write like this. So M is equal to K upon 2 pi square into T square. This is your line equation. Now you see, line equation is what? Y is equal to mx plus c. Since c is 0, this is the y-intercept. What is y in this case? This is y. This is the is the slope, and this is your x-axis. If you plot mass on y, so if you plot mass on y on this y-axis and t square on the x-axis, you would get slope as k upon 2 pi square. So it would be a straight line because k is just one value which is constant for a spring, given a spring. Spring we haven't changed, right? So spring is, this is constant, 2 pi square is constant. So we would get a straight line, right? So in the
Yeah.
vertical axis we have to write m, and on the horizontal axis we have to write t square. Second part, it is saying briefly describe how the slope of the graph would be analyzed to determine k constant. So what is the slope? K upon
Okay.
2 pi square. So when we find slope, which is equal to m, so m into 2 pi square is, k would be equal to that. Thanks for watching. If you like the video, then please like it and subscribe the channel. We will bring more problems along with the solution. So if you have any query, then you can WhatsApp me. If you want a private tuition from me, then you can scan this or send me an email on forcetra.physicss@gmail.com. See you in the next video.